My name is Gadiel Sinditama, student ID 131-18226. Today I'll talk about the creep phenomena for heat-resisting alloys. First, what is creep? Creep is a tendency of a solid material to move slowly or deform permanently under the influence of persistent mechanical stresses. It can be defined as a time-dependent for deformation at elevated temperature and constant stresses. Normally, creep occurs when vacancies in the material migrate towards screen boundaries that are oriented normal to the direction of the applied stress. Creep testing. Creep testing is done by doing tensile testing. Constant stress will be applied on the specimen at a constant temperature. Stress is applied by hanging a weight on the specimen. The results are compiled and made into a strain versus time graph. Creep testing should be conducted using a material tester, since speed control is critical to measuring the deformation over time. This test method is used to determine a sample's creep properties when subjected to a prolonged tensile or compressive load at a constant temperature. The rate of deformation of a sample material to stress at a constant temperature is known as the creep rate. Creep usually occurs at elevated temperatures. Therefore, testing for it usually requires a testing chamber in which the temperature can be altered. Here we can see the diagram of how creep is tested. First, the unloaded specimen is heated to a certain temperature required for the experiment. Then the gauge length of the material is measured. The predetermined load is applied quickly without shock, and then extension measurements will be done at frequent intervals. Around 50 readings should be taken. Coble creep. What is Coble creep? Coble creep is an example of diffusion creep. It occurs by the diffusion of matter along grain boundaries. Under the action of externally applied stress, matter diffuses from grain boundaries in compression to those in tension. Individual grains elongate and macroscopic creep ensures. To date, Coble creep has been derived only for simple periodic gain structures in a mechanism for the formation of crystalline solids. Coble creep is similar to Nabarro-Heeren creep in that it is dominant at lower stress levels and higher temperatures than creep mechanism utilizing dislocation glide. The Nabarro-Heeren. This is also an example of diffusion creep. It is a mode of deformation of crystalline materials. Just like Coble creep, it occurs at low stresses and high temperatures. What are the stages of creep? Creep occurs in 3 stages: primary, secondary, and tertiary. In stage 1, or the primary stage, primary creep occurs at the beginning of the test, and creep is mostly transiently, not at a steady rate. Resistance to creep increases until stage 2, or the secondary stage, is reached. In the secondary creep, the rate of creep becomes roughly steady. This stage is often referred to as steady-state creep. In the last stage, or the tertiary creep, the creep rate begins to accelerate as the cross-sectional area of the specimen decreases due to necking or internal voiding decreases effective area of the specimen. If stage 3 is continued or allowed to proceed, fracture will occur. These are the effects of increase in stress and temperature. With either increasing stress or temperature, the following will happen. The instantaneous strain at the time of stress application will increase. Second, the steady state of creep rate increases. Third, the time to rupture or fracture will decrease. In other words, fracture will occur faster. Larsen-Miller parameter. What is Larsen-Miller parameter? It is used to predict the lifetime of material versus time and temperature using a correlative approach based on the Arrhenius rate equation. The value of the parameter is usually expressed as LMP equals to T multiplied by C plus log TR, where C is a material-specific constant, T is a time in hours, and the big T is a temperature in Kelvin. Heat-resisting alloy microstructure. First, the grain size reduction. By decreasing the grain size, strength and toughness of steel will be increased. Second, equiaxed microstructure. What does equiaxed mean? It means that in all directions the grains has the same dimensions. This is achieved by heat treatment. Third is the single crystal superalloys. A single crystal is a solid material in which a crystal lattice of the entire sample is continuous and unbroken to the edges of the sample, with no grain boundaries present. Single crystal superalloys are produced through directional solidification techniques, whereby the final component comprises only a single grain. The absence of grain boundaries in single crystal superalloys requires for superior creep and thermal fatigue resistance. Thank you for listening to my presentation.